All right, welcome to tutorial number 2 for Calcusign. At this point, you should know how to log into Calcusign, and we'll start all of the tutorials at this tool suite. So again, right now, we're just working on the pylons, but coming soon, blade signs, wall signs, awnings. We're working on them, and when they're available, we will add them to the suite. So you're logged into your account and you want to make a new pylon. So we will start here, create pylon. All right, so we start here. Again, all your overview information, just type it in here. Tutorial number 2. And for this one, we're going to show you how to do a single pole pylon about 20 feet with a base plate design, so that you could design your base plate for an anchor bolt setup. So tutorial number 2, base plate design. All right, again, you can put your project manager information. All this will come along with your project when it goes into our project management software and you submit for final engineering. Just make sure you have your emails in here. Again, any notes that you feel are relevant to this project or to anybody else that might be looking at this in your team, you can put here, and this will go along with the project the whole time, and it'll be saved in your list of projects, which we'll show you in a little bit. Notes, and then again, you can upload any files, brand books, things that would help, soil reports, anything like that. You can upload here. We'll throw our logo in, upload to the site. And now it's saved in your project files, which will go along with the project as you go. So again, you pick your site. We're going to do our offices again. All right. Remember, you have to, once you put your info in, your address and your site name, you have to hit get wind speed, wind data, in order to update the wind speed in the snow load. So we have criteria to start running the calculations with. All right. So now hit next to the cabinets. For this one, we said we do 20 feet. Let's make that 8 foot, and we'll do this by 3. And for this one, you know what? Let's say there's 3 different cabinets on this one. As you hit the Add Cabinet button, it will add a second cabinet to your list, and you'll see it's tabbed out over here. It will replicate the size you have in the prior cabinet, and then you could change it per cabinet if need be. So if you wanted this one to be 6 feet wide, you just do that, and it'll change it over here. So, and you could do that as many times down to grade as you need to. Add another one. So for this one, let's do 3. So single pole, 3 cabinets, different sizes. We picked our criteria. If we need to change anything, we can tab through here. Cabinet 2 if you wanted to change, or top cabinet, whatever you need to change, you can do that. All right, so we picked all our cabinets. Moving on. Now we're going to be on our support page. Again, this is a pylon over 15 feet, so aluminum will not be available in your material type. We're not going to do direct burial this time. We're going to do base plate, so we'll click base plate. Once you do that, you'll see that the pole changes, and it shows you that it's no longer going into the footing itself, and that's where we'll be designing the base plate at grade. We're not going to add any splices or extra supports for this one. We're just simply going to do a simple single pole, 3 cabinet base plate design. So now we will go to the next page where we'll pick our poles. For this one, let's go with a pipe instead of a square tube. So we'll pick pipe here. And again, based on all the criteria we put in, it's sorting by outer diameter. It will pick the smallest value engineered shape for this size sign for the wind load area that you're in, and that is what it will start with. If for some reason, aesthetics or cabinet size or something, you need to increase that size, you can always go to the drop down and you can increase to any other size above. Obviously, anything above the value engineered one will always work. So for this one, we will keep it at the 6x, and we will go to the next step. This is where you'll pick your footing design. Again, as you change the diameter here, it will change the depth below grade to the minimum. So for this one, it's starting at 6. let's call this a 4 foot and minimum 66 inches. So it did 5'6" for minimum depth. You can change this to square if you'd like, but for this one, we'll keep it at round. Going next. Now, this is an option that you haven't seen if you watched the first tutorial because we didn't do a base plate. This now pops up when you do base plate for the design part of base plate. Now, it will start with minimums. There's a little back and forth in this step because you have to check things and look at the design calculations, which are this second tab here, which you'll see right now. This one is failing for the plate thickness and bolt combined shear and strength. So what we wind up doing here is kind of increasing things until we get the design to work. So for this one, minimum is 9.6. It started at the minimums for the plate, but typically you're not going to have a 9.63 plate. So this is where you guys can use what you guys would like to standardly build and how you typically do things. So something this size, we in the office will probably start with like a 12 by plate. And then as we go through, it'll say plate does not currently meet design requirements because we started changing some things. So we have to do the changes until we get all of the design criteria to work. So minimum on the thickness is 1.15. Let's do 1.25, and then go down to plate strength. We have two strengths here. We have 3,600 and 5,000 PSI steel. Start with the minimums. That's your standard steel. If you need to increase for design reasons, you could do that later on. So now let's go back here. So now we have a plate thickness. We increase that to the 1.25. We got that to pass. Now all we have is anchor shear and bolt combined bending. So all that's gonna be down in the bolt area. Here you can pick your weld sizes. It starts at 3/16 for something like this. You can go up to a quarter. This you could pick again based on how you like to design things. It'll allow for the minimums, and then you could increase as you go. If for some reason the weld size that you pick doesn't work, it'll tell you that in the design calculation area, and your shear weld strength, your flange weld, and your tension of the weld will fail. On this one, we have to pass. So moving down to anchor type, which is the last part that we have to fix here for this design to work. So anchor type, diameter for something of this size, starting with a 1/2 inch, probably not your best bet, but it does start with not a minimum that works for this base plate area. It starts with just a minimum that the program sees to start the calculations, and then you need to manipulate it to get a working model. So if we change these to a 5/8 bolt, let's say, we go back here, see if we change any of that. We did not. So really increasing the anchor type or grade is your best bet. We'll go with grade 55. And depth of the anchor, we have minimum as 6. Let's say we want to change that to a 12-inch anchor bolt depth. All right. Bolt row spacing will dictate your strength of the bolts and the tension that they get. So if you are still failing after increasing your bolt sizes with shear and bending, you want to space them out. So for this, we have a 9-inch bolt pattern, but maybe we want to go to like a 10. So if we do that, then our plate size also needs to change, which it did here to get to the minimum with a 1.5-inch end. Let's change this plate. Again, we did a single pole sign at 20 feet, so you're going to need a substantial base plate for this one. All right, so we get back down to here. We'll go with the bolt change and weld. All right. So pretty much you just have to go back and forth with the design here in order to get a working model. And once you do that, it will allow you to move on to the bolt combined bending. Maybe we might need 3 for this one because it is a large sign. There we go. All right, so that did it. So again, we picked a decent sized sign for one pole. So the plate needed to be a little bit bigger, had to increase some sizes, and then that extra row of bolts just brought all the anchors into a pass situation, and everything works. So now we can go to the next step, which would just be our final step. Now, if for some reason you got caught up on this step, because it is a little bit more in depth than just running through the direct burial, there's this request engineering button right here. If you click request engineering, the whole design goes away, and we will have that come into our project management software and know, okay, you guys couldn't get a base plate to work. We will add all that stuff for you. No additional charges for this at this time, and we will put that on the final printout when we stamp. And then you guys have what you need. But in this one, we got it to work, so we could run through to the next step. Next step, final step. Again, everything from the overview in the beginning came through, all of our information. And if there's any other notes that you need to tell us at this point, let's say you had issues with the base plate and you click that, you can say whatever the issue was you were having. Couldn't get the length to work or something. Length not working. That way we could know where you guys got caught up and have all the information on our end. At this point, you can save your project, which will save it into your list of projects. You could download what you just generated, and since we got a working model, again, you have your first page, which will show you your project description, title, address, and where it was located with your map. Second page will be your design. So for this one, you have your 3 cabinets, the sizes, 20 foot from grade, single pole. Again, the single pole at that height with that much wind force needed to be a decent sized plate. We wound up making that plate working over here, and it shows the three bolt design that we got to work. You'll also get your output, design output. Again, this is not a full calculation packet. It is just design output. This is the finals that shows everything worked. So you can see for your base plate checks, everything is true. All that passes. Your footing shows you the concrete yards you need, the bearing pressures, and all the torque and moments from each one of the cabinets and how much that put onto the support. This is typically enough to get this submitted into a township. And again, if they need further detail, we can put another calc packet together. Then your note page, and that's how this one works. Go back. Let's say you show that to your client. They love it. Yes, we need engineering. You can now go back into your project and now send it to us. So at this point, we didn't do the base plate requested assistance because we got it working. We didn't do any spread foot assistance. We don't need the formal calculation packet. Let's say we know in this area the design output is just enough, but we do want hard copies. So we'll check the hard copy. The address on file is what pulls to this again. We're going to want to change this to a different address. How to go to a different place, and we put that in here. Once we have everything we need here, your extra hard copies were $30. This sign was under 25 feet, so it was only $200. And with your hard copies, it's a $230 total. If this is all good for you guys, you confirm here and then submit. That'll take a couple seconds, and it'll say, congratulations, project submitted to Murdoch Engineering. That's how easy this is. That's the whole point of this program, is to just be really easy, really user-friendly, and just try to get the sign companies to be able to do more accurate estimates quicker without really having to involve your engineer until you need to. So that'll conclude our tutorial number 2 on how to do a base plate design. Please take a look at the next ones, and we're going to continue adding more tutorials just to help show you guys how this product, how this program can really help in your workflow. All right, thank you very much. Have a good one.